Hello everyone. In this video we'll talk about trigonometric ratios. And when we think about trigonometric ratios, right away we will think about sine, cosine, tangent, and the reciprocal trigonometric ratios like cosecant, secant, and cotangent. Trig ratios are very relevant, related to the right angle triangle. So if I have this right angle triangle and this is my theta here, then this is going to be my opposite side, this is going to be my adjacent side, and the side that is opposite to the right angle here, that's going to be my hypotenuse. So by looking at the ratios here, we'll say that sine is opposite over hypotenuse, and the reciprocal is cosecant, which is 1 over sine, hypotenuse over opposite. Now when it comes to cosine, it's adjacent over hypotenuse, and the reciprocal secant, hypotenuse over adjacent. Finally, tangent is opposite over adjacent, which is sine over cosine, and the cotangent is the reciprocal of tangent. So now in this question we need to find all the trig ratios. So we have 6 trigonometric ratios. The first 2, sine, cosine, and tangent, they are the basic ones. So by looking at this, this is my theta, this is my opposite side, and this is my adjacent side. We need to find the hypotenuse side. So hypotenuse is basically a square root of adjacent squared plus the opposite squared, and that's going to be equal to 13. Now we can say sine theta is opposite over hypotenuse, and the reciprocal, which is cosecant theta, is the reciprocal. The next, cosine theta is going to be the adjacent over hypotenuse, and the reciprocal secant theta is basically 13 over 12. Finally, tangent theta is the opposite over adjacent, and cotangent is going to be the reciprocal, 12 over 5. One more. So theta is here. The one here is opposite. This is the side opposite to the right angle, that's the hypotenuse, and I'm missing the adjacent. So if you are missing the adjacent, it's going to be the square root of hypotenuse squared minus opposite squared, and that's going to be 2. So now let's do it again. Sine theta equal opposite over hypotenuse, cosine theta adjacent over hypotenuse, and finally tangent theta opposite over adjacent. Now the reciprocal is 2 over 1, which is 2. Reciprocal here, secant theta, which is square root of 5 over 2. And finally cosecant theta equals square root of 5 over 1, which is square root of 5. Now when it comes to the sine and cosine, we don't accept a radical in the denominator. So what you're going to do, you will multiply by the numerator and denominator by square root of 5 to rid out of the root in the denominator for here and this one too. And when you do that, the answer will be square root of 5 over 5. Square root of 5 squared is 5. Here it's going to be 2 square root of 5 over 5. So you need to put your answer in a simplest form. Now, in the Cartesian plane, we have 4 quadrants. So that's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And when it comes to the quadrants, the trig ratios have signs here. So we use cast. We start from the quadrant 4, and some people will say Aztec rule by starting from 1. You can call it anything you want, basically, what does it mean? It means any angle from 0 to 90. So any angle in quadrant 1 is basically from size 0 all the way to 90 degree, which is pi over 2. Anything within this quadrant, any angle less than 90 will have sine, cosine, tangent, and the reciprocal positive. So all of them will be positive. So for example, try sine 30, cosine 30, and tangent 30, and the reciprocals will all be positive because 30 is less than 90. Any angle now in quadrant 2, like for example 120, an angle between 90 to 180, like 120. So sine 120, cosine 120, and tangent 120, you will notice that all of them are negative, and the only positive is going to be sine. So that's we say S. So A represent all of them are positive. S represent only sine is positive. Here we know tangent is going to be positive, but let's see. An angle in a quadrant 3, something like, for example, here, which is an angle all the way from here to here, an angle greater than 180 and less than 270, right? So it's in here between these two, like 250. So when you do sine 250, you can use the calculator for that, cosine 250, and tangent 250. You will notice the only tangent positive here, only. Finally, if you will try an angle in quadrant 4, and here we are going to talk about this angle from here to here, and we are taking an angle in a counterclockwise direction. Then we'll try for something like sine 300, cosine 300, and tangent 300. We will notice that cosine is positive. That's why it's SC. So cast rule or Aztec rule. That's a very important rule when it comes to trigonometry. So now in this question, they want us to find the exact value of each of the remaining trigonometric functions without using the calculator. So if I will draw here something, they said theta is in quadrant 3. So if I would draw an angle in quadrant 3, and it has to be in standard position, so an angle in quadrant 3, I'm talking about this angle from here to here. Okay. If I know the angle in quadrant 3, usually, since this is cosine, that's an adjacent over hypotenuse. So if I created a right angle triangle, and let's say that this is my theta, then this is an opposite, this is an adjacent, this is an hypotenuse. Now we know that the adjacent is equal to 4, hypotenuse is equal to 5. We ignore the negative now. We need to find the opposite. So opposite side will be equal to the hypotenuse squared minus adjacent squared. And that's going to be equal to 3. Now you can say sine theta equal opposite over hypotenuse, tangent theta equal opposite over adjacent, secant theta, which is the reciprocal of cosine, cosecant theta is the reciprocal of sine, and cotangent theta is the reciprocal of tangent. Then we need to study the sine in quadrant 3. So based on the cast rule, tangent is positive here. So what happened? We will give negative here, negative here, negative here. Tangent and its reciprocal are going to be positive. Let's try this one here. First of all, secant is what? Secant is the reciprocal of cosine. So if this is 1, that's going to be hypotenuse and this is adjacent. Okay? So let's say that this is theta, for example. That's an opposite, hypotenuse, and adjacent. And we know that the hypotenuse is 2, adjacent is 1, and we don't know the opposite. So opposite equal a square root hypotenuse square minus adjacent square. That's going to be square root of 3. Now, we can create our cosine theta, sine theta, tangent theta, cosecant theta, and cotangent theta. So now, cosine is adjacent over hypotenuse, sine opposite over hypotenuse, tangent opposite over adjacent, which is square root of 3. Cosecant is the reciprocal of sine, 2 over square root of 3. And I mentioned we need to rid out of square root of 3, so we will multiply both by square root of 3. It's going to be 3. Cotangent is the reciprocal of tangent, so it's going to be 1 over square root of 3. And when you multiply the numerator and denominator by square root of 3, you will get square root of 3 over 3. Now it comes to study the sine. So they said that sine is negative, so we know that it's negative, and its reciprocal will be negative. Now let's think about it here. Based on the rule, cast rule, sine is negative where? Sine is negative here and here, because tangent is positive in the quadrant 3, cosine is positive in the quadrant 4. Now what about secant? Secant is the reciprocal of cosine, and the sine is positive here. So now sine, if I will do it this way, sine is negative here and sine is negative here. But what about cosine? Cosine is negative here, cosine is positive here, and I want it to be positive. So which quadrant we are doing? We are talking about this quadrant here. We're not talking about this one. So theta belongs to quadrant 4. So since it's belong to quadrant 4, then cosine only positive. So this is positive, negative, and negative. Okay, so we decided the sign at the end. Okay, now we will move into something called a reference angle, or we might call it a related acute angle. I like the term related acute angle because it represents the size of the angle. So we know that it has to be an acute angle, and it has to be less than 90 degree. Okay, it has to be less than 90 degree. So now, so an acute angle, an reference angle is an angle. It's an acute angle, so it's less than 90 between the terminal arm and the x-axis. The related acute angle is always positive. It has to be positive and an angle less than 90. So let's think about it here. Where is the reference angle here? So basically from here to here, this is an initial side, that's a terminal side, all of these things, and that's an angle in a standard position. And because it's an acute and in quadrant 1, so let's call theta. So the reference angle is basically the same as theta. It's the theta here, the same one. So reference angle is going to be the same angle as the principal angle. Now in this case, let's look at the initial side here, terminal side here. That's an angle in quadrant 2. Let's look at the angle theta. That's theta. Okay. Where is the, they said I'm looking for an acute angle less than 90, and it's the angle between the terminal side and I will call it the closest side of the x-axis. By looking at this angle here, which one is closer to the, where is the acute angle and the x-axis? We are basically talking about this angle here. Okay, so that's going to be my reference angle. That's going to be my reference angle. How do we find the size of this angle? So basically, from here to here is 180. If I know theta, let's say theta is 120. So reference angle will be 180 minus 120. So that's going to be 180 minus theta. Now, so that's if it is in quadrant 2. Now, what about if the angle is in quadrant 3? So that's my initial side, my terminal side here, and I'm talking about this angle from here to here. That's theta. Okay. Where is reference angle, the acute angle, and the positive the x-axis, sorry. We're talking about the angle here. This one here. That's my reference angle. It has to be an acute angle. How do we find the size of this angle? Well, we know something. We know from here to here is 180, right? 180. And this is an extra, something additional. So it's basically 180 plus, theta minus 180, my bad. Theta minus 180. Okay, one more time here, one more time. So one more time here, look, so that's its initial side, a terminal side. That's my theta, that's theta. If I go, the reference angle is going to be the angle here, the small one here. That's my reference angle. So if I know that theta, let's say, is 250, and I know that from here to here is 180, so 250 minus 180 is going to be my reference angle. Finally, if the angle in quadrant 4, okay, if the angle in quadrant 4, we are talking about this angle from here all the way to here. Where's my reference angle? My reference angle is whatever left. That's my reference angle. So how do we find that reference angle here will be, we know that the angle from here all the way to here is 360. If I subtract 360 minus theta, which is in the blue, I will get the reference angle. Okay, I will get the reference angle. So now in this case, in this question here, determine the related acute angle or the reference angle for each of the following angles. So we'll start with 165. Okay, so for 165, it's an angle in quadrant 2. So it's less than 180. Let's draw an angle in quadrant 2. So that's going to be 165 degree. Where's my reference angle? Is whatever left from the 180. So reference angle will equal to 180 minus 165. And that's going to be equal to 15 degree. Okay. Now, what about the second one here? So 250. 250 is an angle in quadrant 3. Yeah, 3. That's 250. The reference angle is going to be the angle from here to here. This is the reference angle. Here, this is the reference angle. So reference angle will be equal to 250 minus 180, which is equal to 70 degree. Now, in this question, 330 degree. Well, 330 degree basically is an angle in a standard position, of course, starting at this point here and goes all the way before 360, so somewhere here. Okay, now the reference angle is going to be this one. So reference angle will be 360 minus 330, which is equal 30 degree. Now what about this question here, 16 pi over 3? Well, sometimes it's easier if you convert it into degree to see how many revolutions. By multiplying by 180 over pi, that's going to be 960 degree. Now, 960 degree basically is kind of, if you subtract 360 twice, you will get 240. So it's basically 2 revolution plus 240. So if I will draw the angle, I'm going to go 1 revolution counterclockwise, the second revolution, and then stop here. 240 is an angle between in the third quadrant. So I'm here. Where is my reference angle? Reference angle is this part. So when I decide the reference how to calculate the reference angle, I'm taking only this part from here all the way to here. So it's basically 180 plus the reference angle, right? So that's going to be 240. So I can say reference angle equal 240 minus 180, and that's going to be 60 degree. Now, since he asked me in radian, I have to give the answer in radian by multiplying by pi over 180. That's going to be pi over 3. Okay, what about this one? Negative pi over 4. Well, now since it's negative, we're going clockwise. And negative pi over 4, if you change it into degree, you will notice that it's negative 45 degree. Negative 45 degree is going to be from here to here, right? And since we're talking about the reference angle is going to be always positive, and the closest acute angle is going to be this one from here to here. So the reference angle will be the same as this one, but positive. Okay, so it's going to be pi over 4. Now let's try pi over 3. Pi over 3 an angle in quadrant 1, because pi over 3 is basically 60 degree. So I'm talking about this angle here, from here to here. And it's going to be my reference angle as well, because it's an angle in quadrant 1. So that's everything for today's lesson. Please let me know if you have any question about the reference angle and trigonometric ratios, and see you in next video. Bye bye.